In the previous video, we saw how we could represent this abstract list as a concrete circular array along with a next first and next last pointer, though I'm not showing them in order to avoid cluttering up this diagram, and that would be great. But the only problem is that circular arrays don't exist. Well, that's no problem. When there's an abstraction we want, we can build it out of yet more fundamental abstractions, which in this case will just be a linear array. This is very common in computer science. Okay, so we know that we have linear arrays, and we can emulate this idea of a circular array without too much conceptual backbending. So it might look like this. Conceptually, we'd like a circular array, but what we could actually have is a Java array, which is in this case length 8, one for each of these sectors. And then we'll have a next first pointer, which will just be the integer 1, saying what item the next first item should go in. And likewise, we have next last, which is an integer 5. And you can see that these map to each other pretty closely. Given this picture, if I want to imagine the conceptual circular array that goes with it, I just imagine taking this thing and then gluing the ends together. Or vice versa, I imagine just snipping this array. So if I cut this conceptual circular array and straighten it out, I get this actual Java array. There's clearly a clear correspondence between the two. Question for you, is the representation unique? Are there other Java arrays that could represent this? Yes. I mean, it just depends on where we snip it. So if we imagine that we instead snip it in this position right here, in that case, we have position 0 is blank, then position 1 is 3, position 2 is 4, and position 3 is 5. Okay, so obviously that's another choice. And there's no reason we can't end up snipping in the middle of our circular array, so maybe we end up having 5 as this last item. 3 is the first and 4 is the middle, but the 5 actually appears at the beginning of the linear array. Now again, this might seem like, this is getting a little confusing, but it's really not so bad if you just imagine taking this bottom array and then gluing it together. It's just the same thing. So all of these choices are all valid. There's 8 different permutations that would all be the same conceptual circular array. Okay. Now one thing is that this situation will come up when you actually implement project 2 in this class. So I want to spend some time thinking about why this occurs and how this will affect you. Okay. So I'm going to showcase here, I'm going to show on the top of the slide the abstract list. And then on the bottom, I'm going to show the actual data structure as it would appear in Java, roughly speaking. Okay. Now you have some flexibility, but the choice I've made is that I've said, okay, from an empty array list, when I first create an empty array list, it'll look something like this. These are my instance variables. Size is 0. Items is pointing at this array of 8 integers. Next first is 4, and next last is 5. I picked those arbitrarily. You could do next first is 1, and next last is 2, or whatever else. They should just be next to each other. Okay. So then, if I call add last A, then I'm going to fill in that position 5, because I called add last. And then I'm going to increment the next last pointer so that it's now here. Now I'm not showing the actual arrows on the array because I want to emphasize that the pointers aren't real. There are no actual arrows. There's just numbers, and those numbers are going to be used for indexing into this array. If I now call add last B, B goes next, and next last increments. If I call add first, we're going to put something into position 4, so I do add first C. If I do add last 7, or add last and put something in the 7th position, let's say the letter D, then next last wraps around here. That's how we end up having this wraparound effect, and your code will do this at some point as someone is calling these operations. If I now call add last E, the E is in the front, and if you're starting to sweat, just think about it this way. The conceptual list, the abstract list the user has in mind is C, A, B, D, E. I'm always reading from left to right. I just need to start reading from the correct place. Where do I start reading from? From next first plus 1. If I now do add first F, now we have F, C, A, B, D, E. And if we do a couple more add last, let's say G and H, I end up with this array. Now again, this might seem like, oh, now this is super confusing because it's packed in tight. But when we read through the array, we're always going to say that the first actual item in the list is next first plus 1, which is F. And then we just walk through the list. F, C, A, B, D, E, G, H. Okay, so no big deal. Now, once we get to this add last operation, if we add more data, we're going to need a bigger array. Now, when you resize, when you go from your length 8 array to your length 16 array, there's many different positions where the F could end up. For example, if we add last capital Z Afterwards, we double the size of our array, and maybe the f ends up here. In which case, we'd go F, C, A, B, D, E, G, H, Z after copying over to the new array. Or maybe you copy it so that the F goes in the front. Or maybe you copy it so the F goes in position 4. Any of those choices, all of the possible choices are all valid. It's up to you. And what you want to do is just be careful about your design as you're working your way through the project. I should note that using array copy is a bit of a trap on this project. It's a cool idea that you can copy a whole array in one statement. But because of the wraparound effect, I would recommend instead using a for loop instead of array copy, though you're welcome to use array copy if you wish. Just a few little tips about project 2 before I talk about one little last thing. I want you to take things a little at a time. If you try and write a bunch of code all at once, it's going to make you sad because you're going to make some conceptual error without having really thought about what you're doing. If you find like you've written too much stuff and you're a little overwhelmed, just comment out whatever is not necessary and bring it back. In fact, one thing I might recommend is not doing any resizing at all until you know your code works without it. And then you can think about resizing as a performance optimization, like if you want full credit to pass all the tests, to handle arbitrarily sized arrays, then you can implement resizing. Okay? Again, as I said before, using array copy can be really hard to get right. For loops are better. And at least in my case, I'm lazy. I really like obscuring details for myself. So rather than doing math when I was writing my resize operation, like trying to make sure all the pointers are right, I know I already have a method called get. And guess what get 0 gets? The front item. I don't have to figure out where the front item is. I use get 0 and I have it. Now, another little tip is that if you're working and your first try or second try is not going well, it's not so strange to just delete and start over, because the hard part's not the writing of the code, it's building the concepts in your head and then putting them to text editor. I mean, maybe it's a few hundred lines of code, not even that many, it's like maybe 100 lines of code for core functionality. There's really just not that much code, so don't be afraid to throw away your work if you're not happy with it. All right, one last little aside is that this beautiful circular abstraction that I spent all this time talking about, it's not used in, say, Python lists. So if I insert to the front of a Python list, it's not fast. It's actually quite slow. Why do you think that is? Well, the answer is people don't insert at the front of a list very often. It's too rare to justify the extra complicated code you need and the performance penalty that you might get for other operations. So for example, that code has to implement slicing. But if you have a slice from 3 to 9, it may be just because of where all the data has landed, that 3 through 6 is at the end of the array, and then 6 through 9 is at the beginning. Now, if you don't know what slicing notation is, don't worry about that. But point being that there's just other list operations that might get slowed down or more complicated to handle what's not a very common thing in Python. More generally, if you want fast front operations as a programmer, you'll have to make sure to use the appropriate data structure. So if you're in Java, you should be using a linked list instead of an array list. Or if you're in Python, you should be using collections.dec instead of a list. And a dec is just a variant of a list with fast front and back operations. And of course, in our class, your project 1 and project 2 solutions, they're required to have fast front operations because it's supposed to be supporting a hypothetical user who wants dec-like behavior like they have in Python. And so for your array dec, that means you're required to use this circular approach. All right, that's it for today. We've built all the lists we really need to for a while. So yeah, have fun with the project. See you.